Everybody, my name is Krish Verma, and today we are going to study about the H parameter or the hybrid parameter. So, basically, what is an H parameter? Before a transistor was invented in 1947, we had a tool or a gadget called as the vacuum tube parameter or a vacuum tube amplifier. The vacuum tube amplifier, to analyze its parameters, we had to use two parameters, which were namely the Z parameter and the Y parameter. The Z parameter was also called the impedance parameter, and the Y parameter was also called the admittance parameter. These were the two parameters that were used to analyze a vacuum tube amplifier. But after the transistor was invented in 1947, these two parameters were not enough to satisfy the uses of a transistor, which is why we required a third parameter which was able to satisfy all the parameters of a transistor, which is when the H parameter came into use. Now, the H parameter is basically a two port network, and if we can recall, a transistor is also a two port network, which is why the H parameter is also useful for the transistor. Now, the H parameter is a two port network which has an an input terminal over here and an output terminal over here, and it has four variables, namely V1, I1, I2, and here V1 and I1 are the input terminals and V2 and I2 are the output terminals for this port. Here V1 and I2 are dependent variables and I1 and V2 are independent variables. We have to write V1 as a function of I1 V2 and I2 as a function of I1 and V2. For the small signal operations, we write the differential rate law of the V1 and I2 functions. So we differentiate d1 with respect to di1 and with respect to dv2. So it gives us partial differentiation of v1 with i1 and multiplied by the differential of i1, and plus partial differentiation of v1 with respect to v2 and multiplied by the differentiation of v2. And similarly, we can write the differential equation of di2 as. So from these two equations, if we see the first equation, we have dv partial differentiation of v1 and with respect to partial differentiation of i1. So this term gives us h11, which is written over here, and similarly this the second one, which is partial differentiation of v1 with respect to v2, this gives us h12 over here, and similarly I2 by I1 over here gives us h21, and I2 by v2 gives us h22. So these are the H parameters corresponding to 1 1, 1 2, 2 1, and 2. So basically from both these differential equations we get two equations, one for V1 and one for I2, and both these equations are applicable for the common base circuit, the common emitter circuit, and the common collector circuit. Now to find out more about the H11, H12, H21 and H22 parameters, we'll have to go deep into the equations. So if we see the first equation, if we put V2 is equal to 0, the output is short circuited for AC. So H11 will give us V1 by I1 for V2 equal to 0, and this is known as the input impedance. So we can write it as HI, which is the input H11 is the input impedance, and we can write it as HI. And similarly, since V2 is equal to 0, we can write H21 as I2 by I1, which is the forward current gain, and we can write it as HF. Now for the second time, if we put I1 equal to 0, the input open circuited for AC. So H12 will give us V1 by V2, which is equal to the reverse voltage gain, and it is known as HR. And similarly, H22 will give us I2 by V2, which is the output admittance, and similarly it is called as H output, or HO is the symbol. So finally, on combining all these equations, we can substitute H11 as H input, H12 as H reverse voltage gain, and H21 as the forward current gain, and H22 as the output admittance. And finally we will get these two equations corresponding for V1 and I2, which are the dependable variables in terms of the independent variables I1 and V2, which are V1 is equal to HI into I1 plus HR into V2, and I2 is equal to HF into I1 plus H0 into V2. Thank you so much.